video, we are going to look at the revision question in hybridization, and our point of focus is going to be Jamb chemistry. So, if you are praying for the upcoming Jamb and you are still having issue with hybridization in organic chemistry, then you really want to stick to the end of this video. I've done a complete video on what hybridization in organic chemistry. I will leave the link at the description below. You have to check out that video because that video is a complete video on how you can understand the sp3, the sp2, the sp, and everything you need to understand about hybridization in what organic chemistry. So before we start looking at those questions in Jamb chemistry related to what this topic here, now there are some settings you have to put in your mind when you are going to answer question on hybridization. So carbon in organic chemistry is having what three type of hybridization, which is what the sp3, the sp2, and what the sp. Do you get that? So I'm not going to explain how these ones are before because I've explained in details how we form the. Now why is it called sp3, why is it called sp2, and why is it called sp, what happened here, how is it formed. I've already done a video on that. So sp3 is called saturated. It's called saturated hybrid orbital. So all organic compounds that possess the sp3 hybridized orbital, they are called saturated hybrid orbital. An example is called the alkenes. They all have what a single bond. Now this single bond is called sigma bond. Do you get that? So when you see sp3 hybridized orbital, now it's called saturated. An example of compound that possess the sp3 hybridized orbital is called the alkenes. They are what single bond. Do you get that? All single bond are called sigma bonds, and the hybridization is what sp3. Do you get that? Now sp2 is called unsaturated, and there's a reason why it's called unsaturated. So that is the reason why I said if you have not watched the complete video on hybridization, you have to watch that video. You do that. It's called unsaturated, and is that what a double bond? A double what bond? Now the double bond contains one sigma bond and one pi bond. One sigma bond and what? One pi bond. You have to what take note of that. Example is what is the alkene. Do you get that? So compounds that possess a double bond are called sp2 and are called unsaturated. Do you get that? Now sp is also called unsaturated, and it contains what? Triple bonds. So whenever you see a triple bond in organic compound, it's what? sp. You get? So it contains two pi bond and one sigma bond. Do you get? Two pi bond and what? One sigma bond. You have to understand this stuff here. Example is what? Is the alkyne. Is the what? Alkyne. So these are stuff you really need to put on, but you have to answer so many questions relating to what this hybridization here. Do you get that? So now let's take question one. Let's take the first one here. It says the carbon atom in ethene R. Is it sp3? Is it sp2? Is it sp? Is it not hybridized? So these are regular questions you see in Jamb chemistry. So you will not pay close attention here. So ethene is two carbon atoms. So whenever I see the "in," it's called what? Alkene. You get? So it means that now when I see the suffix ene in any hydrocarbon or in any organic compound, now there's a double bond. You get? En means what? There's a what? Double bond, and it's like this ethene, this one here, this prefix here means that what? Is that mean carbon atom? Two carbon atom. So two carbon atom joined by what? By a single bond. Do you get that? Now, this one means that the double bond here. So a, a second bond will be here. Do you get that? So all alkenes have what? A double bond. Do you get that? So remember, carbon must have how many bonds? Carbon must have four bonds. So every carbon atom here must have four bonds. You get? So since there's a double bond here, it means that this carbon atom need to have its four bonds. And for it to have the four bonds, it need to have two hydrogens. So it means that two hydrogen bonded to this carbon atom and two hydrogen were bonded to what? This carbon atom here. Do you see that? So this is the structure of what? Of the what? 18. You get? Now, this is called fully display formula. Fully what? Display formula. Now we also have what we call the condensed formula, which is CH2 double bond CH2. Do you see that? So it is saying that when you look at this compound here, it contains only what? Two carbon atoms. This carbon here and this carbon here. Do that. This carbon contain a double bond because it contains a double bond. All double bond are what? sp2. Right there. So this carbon contain sp2. This also contain what? sp2. Just that. So the hybridization that occur in the 18, they are just what? sp2. Do you get that? So the option is what? Option C, correct one. sp2. Hope you understand. Now, if for example here they say propene, if they say propene. Now, this in here means what? Double bond. This prop here means what? Three carbon atoms. So you have one, two, three. Do that. So remember, the carbon atom therefore we connected what? With a what? Single bond, right? So this carbon atom is connected to this carbon atom with a single bond. This one connected to the top carbon atom with a single bond, right? Now, this in here means that there is a double bond. There's a what? Double bond at a point. So the double can either be here, the double can either what? Be here. So if I should put double bond there, now this is the, because I placed a double bond there, this is how it look like. But remember, in organic compound, carbon must have four bonds. Do you get that? Carbon must have how many bonds? Four bonds. So for you to what? Draw the right structure here, after you have what? Put the double bond there, you have to what? Give each carbon atom four bonds by placing what? Hydrogen. Do you get that? So this carbon atom here is already having how many bonds? Two bonds. How many bonds is left? Two bonds. So those two bonds will not be what? Two hydrogen. So you have to put what? One hydrogen here. Then what? One hydrogen here. Do you get that? So you know that carbon here is now having how many bonds? Four bonds. One, two, three, four. Right? Now the next thing here, this carbon atom here is already having one, two, three. It's already having what? Three bonds. So how many bonds does it need to become four? One. So that one means what? Hydrogen. Now, somebody here can also say, Chris, can I put it here? They are the same thing. You get? This one must have how many bonds? Four bonds, but it's already have one. Then what it needs more is what? Three more hydrogen. So you have one, two, and what? And three. You get? So what are the hybridization present in this propene? Okay, so this carbon atom here is carrying what? Double bond. So any carbon atom that carries a double bond is what? sp2. sp2. Now this carbon atom it doesn't carry this double bond here. So you also have what? sp2. Now this one here do not contain double bond. They are all single bond. Because that single bond here is what? sp3. Do that. The hybridization in propene are what? sp2 and what? sp3. So I just use this one to what? Explain to you so that you know what? Get the what concept. Do you understand? So you now know the difference between what propene and what ethene. Do you get that? Two of them are what alkene, right? But one is having only sp2, but this one is having what sp2 and what sp3. And the main reason for this is because now these two carbon atoms, both of them carry what double bond. So and any carbon atom that carries a double bond is the what is what sp2. Any carbon atom that carry only a single bond, like only a single bond attached, is what sp3. Do you get that? So this compound here contain what sp2 and what sp3 hybrid what orbitals. Do you get that? So let's move to what question 2. So this is what the second one here. Pause the video and try it here. I would like to comment your answer on the comment section. I really want to hear from you. Say the carbon atoms on ethane are ethane. So remember, ethane is what is the alkane, right? So what are the carbon? What ethane? What are they? Are they the sp3? Are they the what sp2? Are they what sp? Are they the what sp2? Are they the sp4? Are they what sp? Which of them? Please comment your answer in the comment section. I really want to hear from you. You get. So when you talk about ethane, you are talking about what alkane. Alkane. And alkane are all single bond. Do you get that? They are all what? Single bond. Look at some here. They are single bond. Do you get that? So now this one means that it contains two carbon atoms. One, two. Do you get that? Connected with a covalent bond because I talk about alkane, there is no double bond, there is no triple bond. Hope you understand. So instead, I mean that carbon atom here must have four bonds. So three hydrogen will be attached here, making it what four, right? And three hydrogen will be attached here, making it what four. You get? So because they are all single bonds, remember all single bonds are what the sp3. So this one is what sp3. This guy is what sp3. So this compound here contain only sp3 hybrid carbon. So the answer is what is A. Do you get that? So that is the answer. So let's look at another question. Question 3. So let's look at the third question. See that the compound contain. Look at the compound here. Do you get that? So this compound contain a methyl group and a benzene structure. Do you get that? So now remember this one, this carbon atom here, all have single bonds. So you can do it like this: hydrogen, hydrogen, and what hydrogen, right? Like that. Then you have this structure here. You get. So here we have a double bond, and double bond. You get. Now, this structure you are seeing here can also be written as a carbon atom bonded to another carbon atom, 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 bonded to another what carbon atom. Do you get? So at this point here, there's a double bond. At this point, there's a double bond. At this point, there's a double bond here. You get? So this carbon atom, remember this carbon atom here must have, remember carbon must have four bonds each, right? This carbon atom here is already having what? Four bonds. 1, 2, 3, 4. Do you get that? So there's no point of you putting hydrogen here again, right? This one here is having three bonds, so there's an hydrogen here. So here we also have hydrogen, here we also have hydrogen, here we also have hydrogen, here we also have hydrogen. Let me do it some very well. Do you get that? So this structure you're seeing here is also the same to this guy here. So that they're asking what are the hybridized carbon in the structure. Remember, this one here only have a single bond. So you're going to do what? sp3, right? sp3. You're going to be what? sp3 hybrid carbon. You get? Now, if you look at this one, if you look at this, the ring itself, the ring contains carbon atoms with a double bond. This one contains a double bond, this one contains a double bond, this guy contains a double bond, this one contains a double bond, this one contains a double bond. So all the carbon here, they are called sp2. Do you get that? Because they all contain double bonds. So in the sense that here you can say the ring itself is what? The ring itself is what? sp2. Because all the carbon atom in the ring, they are all having what a double. So the ring is what sp2. That is the hybridization that exists in this structure here is called is what the what sp3 and what sp2. So if you want to look at it very well, which will be the right answer? Is it sp2 hybridized carbon atom only? No, because it's not only this one, you also contain this guy. So this one is what is wrong, right? What about this one here? Is it just sp3? Yeah, it contains sp3, but it does not only contain sp3, it also contains sp2. So this one is wrong. Do you get that? Now, D, is it sp3 and what sp? No. Do that. Remember, sp is what is a triple bond, so this one is wrong. So the right answer is what is D. You see how easy it is. You have to do more question. So let's look at this one here. Let's look at this one here. They say that the hybridization of the central carbon in sp3cn. Now, if you look at the question where they say the central atom, the central carbon, right there. So they're asking the hybridization of the central atom in this and the bond angle. So they're asking the hybridization in the central carbon and the bond angle. Now, one thing I didn't tell you or show to you is what is the bond angle and the shape. Do you get? Remember, I told you that sp3 is what is a single bond here. The bond angle is what 109 degrees. So now when I see sp3, what should come to your mind? The bond angle is what 109 degrees. Do you get? Now, in the sp2, what should come to mind, which is what the double bond here. Now, the bond angle is what 120 degree. Right there. Then for the sp, which is what triple bond. Now the bond angle is what 180 degrees. So you need to understand this one here. Now the shape of this one is called tetrahedra. Tetrahedra in shape. I get tetrahedra in what in shape. Now you see these questions in the exam. You see this question what in the exam. So take note of this. Now this one here called triangular planar. So for the what sp for the sp2 which is what double bond and bond angle is what 120 is called triangular what planar. Triangular planar. You have to what take note of this one here. Triangular what planar. Then for the sp now which the bond angle is what 120 is called linear. Linear. Okay, so these are stuff you really want to put on, like you want to put in your mind or master when you're answering a question on hybridization in organic chemistry, especially what when I talk about Jamb chemistry. Do you get that? So sp3 is what 109 tetrahedral in shape. sp2 is what 120 triangular what planar. This one is our here. Then sp is what 180 which called linear shape. Do you get that? So I want to wipe your answer so I can answer this question. Look at the compound here. They say that the hybridization and the bond angle of the central carbon. They didn't say the whole stuff here. They just say the central. They just say the word the central carbon. So here we have CH3 C double bond here N. Do you get? So our focus here is going to be what the central carbon, and the central carbon have what a triple bond. Do you get? Remember, any carbon that have a triple bond is what sp. Do you get? So this is the what hybridization of the carbon, right? Now, what is the bond angle of what sp? The bond angle of sp is what 180 degree. Do that. This is called bond angle. Do that. Bond angle. Do that. So from here now, you can now start looking at the one that is option. So is this the answer? Of course, this is not the answer. Because here I have sp2 and what 180. Is it the answer? This is not the answer. Is it the answer? Of course, this is the answer because it's what sp and what 180. So this is the answer. This is what wrong. So you see how easy it is to what identify the bond angle, the bond angle, the identify what the type of hybrid orbital that exists there. And there are so many questions I cannot explain in this video. So that is the reason why I really want you all to subscribe to this channel and follow through what I'm going to teach you here. I upload videos on a constant basis twice or thrice a week for Jamb students. You get, so you know what? Stick to this channel. Subscribe. Please share this video to your other colleagues or friends that are also writing Jamb chemistry this year. Please, I would really love to hear from you at the comment section. If this video help you, please leave it at the comment section. It goes a long way to tell me that you actually what loving this content, and always give this video a like. Always give our video a like because it helps to spread to other persons. You get. See you in the next video. Sorry, if you really want to learn about everything about the hybridization from scratch, then you can go check out this video. I'll see you there.